another equation, 4x minus 2 plus q equals 5 plus 6q plus 4. Now this equation may look more challenging or bigger than the one we did in example number 1, but it's only because there's a little trick before we get started. Do you know what the trick is? Do you see? Are you thinking that there's a way to make this equation simpler than it currently reads? Well, by simpler, I'm trying to suggest that, hey, we can do some simplifying before we even get started with this equation. I mean, think about these as two algebraic expressions on the left side and the right side. So we got 4q minus 2 plus q. Hey, there's some like terms there. What's 4q plus q? 5q. Minus 2, hey, that's not a like term, so it just stays. On the right-hand side, hey, there's some like terms as well. 9 plus 6q. From this point, this equation is no more difficult than the other equation that we did. So, again, we're trying to isolate the variable. We have q's on both sides. Look for the side with the bigger amount of q's. Hey, that's the right-hand side. That's where we want the q's, which means, well, we need to get them away from the left-hand side. So how do I get rid of 5q? Well, I'm going to subtract 5q. Now, if I do that to the left-hand side, then I must do it to the right-hand side. That's all about the golden rule, right? So we do that, and now we simplify again. We have negative 2 equals 9 plus q. What do we do now? Well, how about we subtract 9 from both sides to get rid of that positive 9. And now what do we have? We have negative 11 equals q. Now, I don't know, is that solution correct? I'm not really sure. Well, here's how we can find out. We're going to check, right? Now, I'm a little crammed for room here, so let's see if I can do this. Just give me a moment. Let's group all this together, and then I can shrink it. There, that'll leave me some room now so I can do some checking over here. All right, so left side, right side checking. Here we go. Left side, right side checking. Well, remember this about left side, right side checking. We have to take the algebraic expressions that are in the question. So this algebraic expression has to go on the left-hand side. This algebraic expression has to go on the right-hand side. Let's do that. So we have 4q minus 2 plus q. And then over here we have 5 plus 6q plus 4. Now if you're thinking to yourself, well, why doesn't he just take the second line right here? And why doesn't he use that for his left side and right side? Well, the answer is because you can't. And now I'll explain a little bit more as to why you can't. You can't use that line because if you made a mistake going from the first line to the second line of the equation, you would never find that mistake when you went and checked it. So you always have to go back up to the question, the original equation, and use that for your left side and your right side. Now, before we go any, so now we substitute, and remember what we substitute. We substitute what we think is the solution, and basically this checking is to see or to check if that solution is correct. So plugging in negative 11 for q. Let's start evaluating. Well, what's 4 times negative 11? That's negative 44 minus 2. Hey, the brackets aren't even doing anything here, so let's just subtract 11 more. Negative 44 minus 2, well, that's negative 46. Minus 11 more, that's negative 57. Now we check the right-hand side. 5 plus 6 times negative 11 plus 4. What does that give us? 5 minus 66 plus 4. we got, lo and behold, negative 57. Why is that a good thing? Well, that proves that the left side equals the right side, which means that our solution of negative 11 must be correct. The only way that's possible, that the left side and the right side will equal each other, is if the the solution is correct. So we know that negative 11 is correct. We've solved another equation successfully.